Okay, thank you for the change. Today I will presenting our publication. The title is Land Surface Temperature Identification based on data of Landsat 8 on Batam Island with the author Octavianto Gustin, Ronauli Manik, Farokidinda Rasarandi, Arif Rozikin from Geomatics Engineering Polytechnic Negeri Batam, Nurlaila Hayati Isa from Geomatics Engineering Institute Teknologi 10 November Surabaya, and Trismono Chandra Krishna from Earth Science SRON Netherlands Institute for Space Research Sorbonne 2 Utrecht Netherlands. Introduction. The Batam city has been planned as a producer of industrial goods with the vision of the Batam city, namely the realization of the city of Batam as a world port of Madani that is competitive, advanced, prosperous, and dignified. It makes an increase of the infrastructure development. For example, many developers take advantage of this opportunity to build numerous housing. Because of the change of land use from forestry to residential and commercial, the green space areas were decreasing significantly. Industrialization and urbanization processes that are coupled with land cover changing weather and climate pattern. This results in elastic difference between urban and suburban area. Where the suburban area tends to be lower, this uneven heat excesses phenomenon is called the urban heat pole. Therefore, monitoring of the ground surface temperature is necessary in order to measure quantitatively the heat surface in Batam Island as a parameter of global climate change. Nowadays, the measurement of LST using the remote sensing technology is very popular since it covers the regional scale efficiently. Even it can take any further to a global scale, we use Landsat 8 satellite image provided by USGS and process this image to generate the value of LST. Furthermore, the result of Landsat 8 was validated to the ground measure LST. 2. Research method. A. Cloud masking. Clouds are one of the most common atmospheric disturbances in Landsat 8 satellite imagery. These cloud disruptions cause important information that cannot be obtained because they are covered by cloud. Effective solutions to reduce or eliminate cloud disturbance are very important in applying remote sensing. During the stage of cloud masking on Landsat 8, the quality assessment band contained in the downloaded Landsat 8 image was used. Cloud masking is done by using the GIS application, then get to adjust to the study area. The result of this process make the cloud value to 0. This cloud disturbance causes various important information that cannot be obtained because it is covered by the cloud. An effective solution to reduce or eliminate cloud interference is very important in applying remote sensing. So this is the cloud masking algorithm. This is a cloud separation and cloud elimination. Radiometric correction is a process to improve the visual quality of an image in terms of improving the pixel value that does not match the reflectance value or the actual spectral beam of the object. Another error that needs to be corrected is the atmospheric error, usually caused by the base of the electromagnetic wave radiation that is scattered or reflected by the atmosphere to the satellite sensor. By making atmospheric correction, it is hoped that noise can be reduced or eliminated. The first stage of radiometric correction is conversion of digital number to top of atmosphere radiance. Referring to research, the value of spectral radiance is defined as the flux of radiance per unit at certain angle irradiated by an object in a particular direction. Landsat S image data on the sensor is located in the band 10, 5, and 4 to calculate the surface land temperature. The conversion is done to get the satellite sensor radiance value because the target is on the ground surface while the sensor is in outer space. Atmospheric, atmospheric radiance can be obtained from this algorithm where a lambda is TOA radiance on the camera sensor and ML is rescaling constant and AL is enhancer constant. Convert pixel value to top of atmospheric value reflectance. Reflection value is the ratio of the energy reflected from the total energy affecting a surface per unit area. For thermal band, calibration is only done until the radiant value is corrected, whereas for band that appear to need further calibration, i.e. atmospheric calibration. The equation for converting radiance to reflectance is follow this algorithm, where P lambda xn is processing result without correction of the taking angle, and P lambda xn doesn't contain the correction for the sun's angle. MP is rescaling constant, where reflectance multiband. AP is rescaling constant, reflectance at band, and sin theta s is sun's zenith angle when recording. Geometric correction. Geometric correction is the positioning correction of the position of the image so that it matches the actual coordinate of the Earth because the geographical position of the image at the time of data recording is distorted or there is an error during the sensor height, position change, time difference, image acquisition. To minimize this error, then classify geometric correction into two groups, namely orbital geometry and transformation based on field control point or ground control point. The magnitude of the shift is shown by the magnitude of the root mean square error, which is the standard deviation of the x cell and y cell distance resulting from the transformation of the coordinate transformation result. RMS error is the distance between the input location of a KCP and the same KCP transformation location. To find the amount of RMS error, the following equation is used. Is the algorithm below, where x residual pixel is the difference between the column before and after the transformation, y residual pixel is the difference between the column before and after the transformation. The degree of shift in determining GGP is indicated by the large RMS value. The smaller RMS value is the better placement of pixel points in the corrected image. The total allowable RMS error is 0.5 pixel. The image classification. Image classification is a process of compiling, sorting, or grouping all pixels into a certain class based on an objective criteria or category. The classification uses an algorithm to study and analyze a number of unknown pixels and divide them by a number of classes based on the grouping of digital value of the resulting class image is a spectral class. Calculation of land surface temperature. LSC in the study area was calculated using a semi-empirical method with an estimate of the surface emissivity obtained based on the normalized difference vegetation index. Value classification. NDVI correction is a measurement of sensitive and very good vegetation using spectral energy difference reflected by the canopy of vegetation and the wavelength of the red and near infrared electromagnetic spectrum. NDVI value are based on wavelength rate and maximum reflected, so the effect of the atmosphere is considered not to have a major effect on the chlorophyll scattering. With the algorithm below, where binary and period reflectance value of channel 5 and channel 4, then vegetation density and land cover are classified as a water bodies for NDVI less than 0, deforested or non-vegetated land for 0 less than equal to NDVI less than 0.2, mixed or vegetated land for 0.2 less than equal to NDVI less than equal to 0.65, and land vegetated meeting for NDVI more than 0.65. Land surface temperature obtained from the infrared thermal channel 10 can be calculated by the Jimenez, Munoz, and Sobrino in equation below, where LST is a land surface temperature, the sensor is inner temperature brightness, lambda is wavelength of the effective radiation emission on the PIR sensor, H is a Planck constant, C is speed of light, G is Boltzmann constant. Brightness temperature is obtained from converting the specific conversion channel of the infrared channel contained in the image metadata by this formula, where K2 is calibration constant 2, K1 is calibration constant 1, and the sensor is effective temperature sensor in Kelvin or the sensor. L sensor is the digital number of channel 10 which is change in radiation. Also, its emissivity is expressed by the equation where epsilon is soil emissivity, F is constant 0.55, epsilon S is the soil emissivity value, and 0.97, and epsilon V is soil emissivity value of 0.99. The working principle of a soil thermometer is the same as the working principle of a thermometer in general. Only the difference in shape and length are different. The measurement of soil temperature is more careful than the air temperature. The slow change affect the density and type of soil. Sampling. The sampling in the study was conducted by a method of taking sample from several points. The question that often arises from research is how large is the sample to be studied from a population. Based on the existing population, then the sampling of the study used the Tamaro-Yamano equation. From this equation, n small is the number of samples, the bigger n is the total population, A is precision significance level. Simple correlation is a statistical technique used to measure the relationship of two variables to find out the form of the relationship between the two variables with quantitative result. The meaning of the relationship is whether the relationship is close, weak, or and not close to being divided into positive linear correlation and correlation linear negative. A simple correlation coefficient that is often used is the Pearson product moment correlation coefficient. And this is the Pearson product moment formula. Pearson correlation was first described by Carl Pearson mathematician who came from England. The formula used to calculate the simple correlation coefficient. 3. Result and discussion. Landsat data 8 on March 24 in 2019 was covered by cloud in several cloud covered districts, namely Bengkong, Batam Kota, Sungai Beduk, Batu Ampar, and some areas that are not covered by cloud. The result of the Landsat 8 LST on March 24 were obtained from composite 10, 5, and 4 with the help of the vegetation index band 5 and 4, so that the LST was obtained on Batam Island. The result consists of 9 classes referred to clouds, with the highest temperature found in Batu Ampar and Bengkong district, the lowest temperature being in the Sekupang district, and moderate temperature are found in Nongsa district. The highest temperature range from 22.8 to 33.1 Celsius degree, spread in several districts, namely Batu Ampar, Bengkong, Sekupang, Sungai Beduk, Sagulung, Batu Aji, Lubuk Baja. The lowest temperature range from 18.7 to 23.1 Celsius degree, found in Sekupang, Tanjung Pinggir. Vegetation index used is in DVI because it is more sensitive to chlorophyll, and the vegetation index value can be used to determine surface emissivity empirically and can highlight the effect of vegetation implicitly. %50 of Batam Island area is covered by cloud, so that it is necessary to identify additional surface temperature on the island of Batam. Complete the information on the surface temperature on Batam Island covered by cloud on 24 March, so that Landsat 8 data on February 4 were used as a data that helps to complete the surface information of the island in Batam. This is a calibration process. A good calibration affects the result that will be obtained by placing a thermometer in a glass of warm water and then letting them stand a few minutes to see change in the temperature that occur. Thermometer planting is done at a depth of 15 cm for the parent soil. All the results are recorded on a worksheet, so there are no errors in the later data processing. The follow results are obtained from the correlation of two variable surface temperature in the field X and surface temperature using Landsat 8 and Y data. Figure 7 notes that the relationship between the two variables above has a moderate relationship, namely in 0.49, assuming the LST result on Landsat 8 with the result measured in the field have a moderate relationship or moderate with a range of 0.30 to 0.49. Conclusion 1. Based on this research, cloud masking was carried out with the aim that the value of the cloud doesn't disrupt the value generated in the surface. Surface temperature measurement and arithmetic equation were performed to reduce distortion in Landsat image recording. Semi-empirical value is the matching of the NDVI value of the speed of light and wavelength by combining the radiant value formula in the 10 channel band, so that the sensor value obtained is the surface temperature in the form of 0 Kelvin, with the surface temperature obtained change in the form of 0 Celsius. The relationship between land surface temperature identification obtained from Landsat 8 image data and measurement of surface temperature by including the value of the interval class K, where K equal to 1 plus 3.3 log n, where n is loss of data or 54 data, so that the value of the interval class in the Landsat 8 soil temperature measurement on March 24 is 7 class. The value of the interval class is used as a reference for sampling point in which field 1 class is a cloud value, so the field sampling is done by 6 classes using the Taru-Yamano equation to determine the number of samples in each class on the result of data analysis explained previously. That the number of samples spread on Batam Island is 36 samples, whereas one class has 6 of the sample point and the data obtained in the field is 0.36. This value included sufficient or moderate correlation in the percent product moment. 3. Based on Landsat 8 only or TIRSS, image data recording on March 24 with the cloudy Batam Island conditions during the research, assist with image data on February 4 to reduce the value of clouds that nearly covered 50% of the area on Batam Island. Okay, that's all the presentation, and thank you for the attention.